In this video, we're going to take a look at IUPAC Nomenclature. So IUPAC Nomenclature is a method of naming our organic compounds systematically. So that means that based on the name, we'll be able to determine the structure of our organic molecule. So, if we're looking at a typical alkane, like I have shown here, in order to determine that structure, so there are several key things that we need. The first thing, of course, is we need to know how many carbons we have. So in this case, we have one carbon at every vertex of our line. So that would be 4 carbons, right? So we know this is a C4 alkane. And then, of course, according to our CnH2n plus 2 rule, we would have 10 hydrogens. And of course, we could draw those in if we want to as well, with hydrogens on each of our carbons to get our full 4 bonds for each carbon. So the first thing we need in our naming system is something that tells us how many carbons we have. So for that, we're going to use a series of prefixes that tell us the number of carbons. So we'll have our numbers here based on the number of carbons. We have, we'll commonly see 1 through 10 carbons. We do have numbers for our prefixes for greater than 10 carbons, but we don't commonly see those in organic chemistry, so we won't worry about them. So for each number of carbons, we'll have a separate prefix. If we have 1 carbon, we use the meth prefix. So that would indicate a single carbon. So I'll go ahead and draw out my single carbon here. Now, of course, as we know, this is an alkane because it has carbon and hydrogens only, with no carbon-carbon double bonds or triple bonds. It's only carbon-carbon single bonds. So since we have an alkane, we're going to use a portion of our alkane name to indicate the fact that this is indeed an alkane. So we use that ane ending from our alkane. We use that meth prefix from our IUPAC nomenclature. We combine these together, and we get methane. So a 1-carbon alkane is methane. We can continue this for our alkanes as they get larger. We have F for a 2-carbon alkane, prop for 3 carbons, bute for 4, pent for 5, hex for 6, hep for 7, oct for 8, none for 9, and dec for 10. So we can easily identify our alkane size just based on these varying prefixes to indicate the number of carbons. Now, of course, knowing the number of carbons is very important, but it doesn't tell us everything we need to know about a compound. So, let's say, for example, we take C4H10, and we instead draw our 4 carbons out like this. So we still have our 4 carbons, represented again at each vertex, and we would still there also have our 10 hydrogens, as indicated by our generic alkane formula. But our bonds and our connectivity for our molecule is different here than it was with our C4H10 molecule that we drew before. So this right here is what we call a constitutional isomer, or structural isomer. So this refers to a molecule that has the same formula as another molecule, but differs in how our atoms are connected together. So here we have that central carbon that's bonded to our 3 other carbons. Here we have all of our carbons bonded in sequence. So with our nomenclature, we need a method to distinguish between these 2 different isomers. So what we're going to do in order to distinguish these is our first rule for nomenclature is going to be to find the longest consecutive chain of carbons, and we're going to use that to find our base name or parent name for that main chain in our molecule. So find the longest consecutive chain of carbons. So in this case here, we would have 1, 2, and then we could go in either direction, but in both cases we'd end up with our longest consecutive chain of being 3 carbons. Right? We don't want to turn back and go back and count this carbon. We are always just going in a straight line, or not necessarily a straight line, but we're always going from one carbon to the other. We never want to backtrack when we're counting that consecutive chain. Over here we have 1, 2, 3, 4, that longest consecutive chain. It doesn't matter in which direction you count. So let's say we have a larger molecule here. So you can imagine there are several different possibilities for counting this. We could go 1, 2, 3, 4, 5, 6, 7, 8. That would be one possibility. But we could also start down here and go 1, 2, 3, 4, 5, 6, 7, 8, 9. So my orange option here gives me a longer consecutive chain of carbons. So I would use that as my parent chain. So my parent chain is indicated there. And I would use then that as the base for my name. So my parent chain includes 9 carbons that I just counted out. So I look over here, I use the known prefix for my 9 carbons, and I would name this as nonane, my alkane with 9 carbons. Now, of course, so that tells me what my parent chain name is, but I still need something that's going to allow me to account for these groups that aren't on my parent chain that are coming off of my molecule. Right? So if I look at a molecule like this, for example, so this was my isomer of the C4H10, this would be my parent chain here, my longest consecutive chain of carbons. So this would be propane then, based on my 3 carbons. But again, I haven't given anything in my name to indicate this extra group over here. Right? There's nothing to distinguish this propane versus the propane that we've seen previously, which would just be our simple 3 carbons in a straight line. Right? So there's nothing in my name right now to distinguish between these 2 structures. So we need something that we can use to name these groups that aren't a part of the parent chain. So we're going to call these branches. So we have kind of our main trunk, our main chain for our alkane, and then we have individual smaller branches coming off of that main chain. So what we're going to do for our branches is we're again going to use our prefixes to indicate how many carbons there are on our branches. But now we're just going to end it with YL to indicate that it's a branch. So all of our branches will have a YL. We get the name of our branch, and then we can just stick that in front of our name for the parent chain to indicate our name for the molecule overall. So right here, of course, we have a single carbon, so that would be my meth prefix. I add the YL, methyl, and this would be methyl propane. Over here with my nonane, I have one branch here. This would be methyl because it has a single carbon. I have another branch here. This would also be methyl, since we have a single carbon there as well. So I have 2 methyl branches. Now I could just write those in here. I could say methyl, methyl, nonane, but that makes my name longer than it really needs to be. So instead what I'm going to do is just say dimethyl. Di, of course, is our common prefix for 2, right? Indicating that we have 2 1-carbon branches, right? Di indicating 2, methyl, or meth indicating 2 carbons, and of course our YL indicating that this is in fact a branch. So this is the second key step of our naming. Name branches based on number of carbons. Okay, so now we have dimethyl. So this would be dimethylnonane. I should mention we could also have trimethyl or tetramethyl. That would be indicating 3 or 4 methyl groups, or even pentamethyl would be if you have 5 different methyl branches coming off of your parent chain. Okay, so that gives us a good start. Now, dimethylnonane. So that tells us we have a 9-carbon parent chain with 2 methyl branches. Is that everything I need to know to draw out my structure? Let's test ourselves. So let's take my 9 carbons. So I'm just going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 carbons. It doesn't really matter that I didn't draw it in exactly the same orientation as my nonane over here. These carbon chains are flexible, they can move around. I could turn this up to match that over there. It doesn't really matter how you draw it here. It really just matters where things are connected, not kind of the overall orientation of how things are rotated. Okay, so now I need 2 methyl groups, right, according to my name. Well, let's say I just draw one here, and I'll draw another one, I don't know, let's put it right over here. Is this the same molecule as my other dimethylnonane here? So if we look at it, they look fairly similar. In fact, I can even, let's go ahead and try to redraw it in the same orientation, just to make it even more clear. So I'll start with my 9 carbons. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have a methyl group coming off here, and another one over here. Now as we compare, we can see, okay, my parent chain is in the same orientation, but my branches are connected at different carbons, right? So I drew, it's still a dimethylnonane, right? So here's my parent chain, and here are my branches. So I still have the same dimethylnonane, but my branches are in different spots. So I need a way to distinguish where those branches are placed. So what I'm going to do is I'm going to number my carbons, similar to what I did here when I was counting my carbons, and I'm going to use those number positions to indicate where my carbons are, or where my branches are. So right here, let's get rid of these pink numbers so that we're not confused. All right, so now looking at our orange numbers that we've used to number our carbons. This is our first carbon, second, third. So we have a methyl branch coming off of that 3rd carbon. 4th, 5th, 6th. We have a methyl branch coming off of the 6th carbon. So we can then just indicate those numbers here. So 3 and 6 to indicate the positions of each of those branches. And we'll use a little hyphen to separate those from our name. So this is 3,6-dimethylnonane. Now, it's important to mention here, so at this point I was counting from my carbon over here on the right side. I could also potentially try to count my carbons from the left, right? So it would be carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So at this point it looks like we could say Oh, it's actually 4,7-dimethylnonane. So to distinguish between these two potential numbering systems, we need to bring in our third rule. So we're going to number carbons such that our first branch gets the lowest number. So the first branch that we encounter should have the lowest possible number that we can get. In this case, if we count using our pink numbers, the first branch occurs at the 4th carbon. If we count using the orange numbers, our first branch occurs at the 3rd carbon. So we don't want to use our pink numbering system. We use our orange numbering system. That gives us the lower branching number. Let's apply that over here. So if we start counting from the left, we would have carbon 1, 2, 3. Our first branch would be at the 3rd carbon. If we start counting from the right side, it would be 1, 2. Our first branch would be at the 2nd carbon. So we're going to use this numbering system starting from the right side. Again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Our branches are at 2 and 7, making this 2,7-dimethylnonane. Okay, so that gives our primary rules for naming our alkanes. I just want to introduce a couple special cases that will finish our naming system. So far, of course, we have our prefix that indicates how many carbons we have in our parent chain. We have our suffix, our ane, that indicates that we have an alkane. And then we also have our numbers that indicate where we have branches, and we have separate prefixes for those branches. Okay, so first scenario. All right, so let's say we have this compound here with two different kinds of branches. Right, so let's count our longest possible parent chain. So whether we count from here or here, we should get the same. It'd be 1, 2, 3, 4, 5, 6. So this is a hexane. So I can go ahead and write down the name of my parent chain. I have 2 branches. I have 1 branch here with a single carbon, 1 branch here with 2 carbons. So this would be a methyl branch, and this would be an ethyl branch, again using my prefix for 2 carbons. Now I again need to indicate my numbering. So if I start here from the left, my first branch occurs at the 3rd carbon. If I start here at the right, my first branch occurs at the 2nd carbon. So I want to use the orange numbering system. That puts my methyl branch at the 2nd position and my ethyl branch at the 4th position. Now, when I put those in my name, I want to put them in alphabetical order. So ethyl will go first. So this would be 4-ethyl, and then I add my methyl, 2-methyl hexane. Okay, so always use alphabetical order if there's different kinds of branches. Branches in name go in alphabetical order. Okay, now our next special case. Let's say we have a slightly larger alkane, and I'm going to have this branch right here in the middle. So let's count my carbons. 1, 2, 3, 4. Now I could get 5, 6 if I went up here, or 5, 6, 7 if I go down this way. So I want to get that longest possible parent chain. But now I have a branch up here that has 3 carbons, but my branch itself has kind of a funny shape, right? So instead of just being a couple carbons coming off in a consecutive chain, I actually have a branch that has a junction itself, right? My branch has 2 different directions that it goes in from my parent chain. So I'm going to name this as kind of almost like a recursive branching system where I need to name my branch that's coming off of my branch, right? So this is my branch, and I'm going to start from my branching point, so that's right here, carbon 1. I count out the longest parent chain of my branch, starting from the carbon that starts the branch, so that'd be 1, 2. I can't count all 3 because that wouldn't be a consecutive chain. Now this is my branch parent chain, and this is a branch coming off of my branch. So it gets a little bit confusing because now we're looking at a branch on a branch. So what I'm going to do now is name this branch. So this is a methyl branch. It's coming off of the first carbon of my parent chain here. This, of course, is also a branch, so I call it a ethyl branch because it has my 2 carbons. So now my full branch, I'll put this in parentheses because I'm indicating that that's the name of my branch, will need to be added to the name of my parent chain. So I go down here, I have 7 carbons. That gives me heptane. I put my branch name in here as well. So this is 1-methyl-ethyl. The 1-methyl is that branch coming off my branch at the first carbon. The ethyl is my 2-carbon parent chain of the branch. And now I just need my number here, that number 4, to indicate that this complex branch comes off at the 4th position of my heptane parent chain. Again, of course, I should always make sure that this is the lowest possible number I can get for my branch. So I'll go ahead and just quickly count from the right. And you can see that whether I count from the right or the left, I get the same number 4 for that central branch. So this would be my final name. Okay, our last special case is going to be cycloalkanes. So cycloalkanes, we have our carbons connected around in a consecutive chain to itself. So it creates a ring-like structure where we have a cycle. Now in this case, with our normal parent chain system, we're always thinking of just a consecutive chain, right? That doesn't work here because we could go around in circles forever, right? So we're just going to count the total number of carbons that create our cycle. So we have 6 carbons in our cyclic system. So as usual, 6 carbons is hexane. But now we need something to indicate that we have this ring shape. So we're going to do that using a cyclo prefix. So this is a different prefix than our number prefix. It's just a prefix that indicates that we have a ring system. Now if we have branches on our ring, we can name them the same as we name them for other alkanes. So if I have maybe a couple branches here, and another larger branch here, I would name those as usual based on our normal naming system. Now for branches on a cycloalkane, we always put our first branch at the number 1 position because it really doesn't matter where we start in our numbering, right? We could theoretically start our numbering anywhere, so we always want to start our numbering at a branch because that gives our branch the lowest possible number. Again, going back to our rule 3 here, where we're trying to get that lowest overall number. So again, I want to do this in alphabetical order. So we have our methyl. This is a dimethyl, 1,1-dimethyl. In terms of alphabetical order, we're just looking at the name of our branch itself. We kind of ignore the di portion of our name. And then that 2-carbon ethyl branch is at the 3rd position to make it 3-ethyl 1,1-dimethyl cyclohexane. Again, with our counting system here, we should also note, so we're going to start where we can give our branches the lowest possible numbers. That's here because we want our 2 branches to be at 1, if possible. In this case, of course, we could count in either direction again, but we count using the orange numbering system because that gives our 2nd branch the lowest number overall. Okay, so this summarizes our IUPAC nomenclature for alkanes. As we'll see later in the semester, we use slight modifications of the same naming system for other organic molecules as well. So as long as we learn these 4 key rules and follow these key rules, we'll be able to name almost any organic molecule.